You might be familiar with the itertools module. And by the way, if you're not familiar with it, you really should get familiar with it. Import itertools. And one of the many tools in itertools is something called itertools.chain. And itertools.chain returns an iterator. It returns a chain object whose next method returns elements from the first iterable, then the second iterable, then the third iterable. What in the world are they talking about? So if I say here s equals abcd, and my list equals 10, 20, 30, I'm going to say t equals 100, 200, 300. So what I can do is I can say here, for one item in itertools.chain, and it's going to take multiple arguments, s, my list, and t. Print one item, and we'll even say end equals space, just so it won't go off the screen. And it's going to go through all the elements in S, then all the elements in my list, then all the elements in T. So each of the arguments to itertools.chain is iterable. But then we go through each of the elements in each of those and return them one at a time in an iterator. So for this question, what I want you to do is implement my chain, which works like itertools.chain. Meaning we should be able to say my chain, or for one item in my chain of S, my list, and T. And then say print one item end equals space. And then that should work exactly the same way as itertools.chain. So how are we going to do this? Well, there are always a few different ways, but the best way here is, I think, going to be to implement my chain as a generator function. So we're going to say here def my chain. And my chain, how many arguments is it going to take? We have no idea. Could be a lot, could be a little, could be none. So we're going to say splat args. Each of the arguments will have to be iterable, but we don't know how many such arguments we're going to get. So def my chain splat args. And then what? Well, now I want to go through each element in args. So I'm going to say for one arg in args. And now what do I want to do? Well, each argument is itself iterable. S, my list, and T. So what am I going to do there? I'm going to say for one subarg in one arg. And then what am I going to do? I can't return. If I say return one subarg, then as soon as I hit return, the function returns. And besides, that won't create an iterator of any sort. When you have return in a function, when you don't have yield in a function, that means it's a regular function. When you invoke the function, you get back, well, whatever the return value is. By contrast, if we say yield, then Python knows that running the function shouldn't execute the body. Rather, running the function will return a generator object that each time we invoke next on it, or each time the for loop invokes next on it, we are going to get to the next item. And so this is actually how we can implement my chain. We go through one arg in args, each of the things that we got as an argument, and then we're going to iterate over each of those for one subarg in one arg, yield one subarg, and now once I do that, sure enough, we get all of the values that we were hoping and expecting to get. So this is a classic example of where and how we can use generator functions to produce iterators easily, cheaply, and quickly, also because the logic lends itself to a function. We could have also added it to a class, but we're not going to do that here at this point. All right, and you also see then that itertools is full of classes and generator functions, each of which returns an iterator that can then be used in a for loop somewhere. By the way, let me just show you before we finish up with this. I can, of course, put my chain in comprehension as well, or all sorts of other places that expect to get an iterable. So if I say here, for example, one item for one item in my chain, S, my list, and T, then we're going to get a list of those elements back. Right? Easy enough. What if I were to say here, stir of one item? So we're going to turn everything into a string. Everything becomes a string. And then, of course, I can say here, space.join on all these. Or, of course, I can remove the square brackets, and now I have a generator expression rather than list comprehension, which will give us the same result, but with a bit more efficiency. So all these things are really connected to one another, and understanding how the iteration protocol works and how we can create objects that use that iteration protocol, both in classes and in generator functions, and for that matter, in generator expressions, is all really important and useful in our work in Python.